Hi there! Welcome to it's a silent Z. Laboratories. Where we're all very smart and we use a notation for our numbers. To write large or small numbers. Because we're too lazy. And so we'll only write numbers up to the 1th place. And then you count as much as you want over there. So, say we want to write 33. Now, this makes no sense because it'd be easier just to hit the three button twice than hitting 3 buttons with the decimal. So I guess that's not the reason. However, that's how we do it. Times 10 to, we multiply by 10 to whatever power. Like, I'm pretty sure you use a caret 1. 10 to the 1st power, you see? Because they're smart. Which would equal 33. Or, more simply, 6.383. If we want to write 638.3, we would write 6.3 times 10 to the 2nd power. You see, because we're smart like that. We're totally smart and we don't mess up anything. So, one other thing we do in these Formazt Lavatories, we use negative exponents. So you wanted, what the heck is a comma doing in there? Say you wanted this number because that saved the amount of substance in. You just want that number. Now we're too lazy to write it, so I forgot one thing because I make no mistakes. You would write this one. You always try and get it to the 1th place because we're too lazy to do anything else. And then you'll use a negative exponent. So I believe that would be 5. Or it would be 6. 10 to the 6th power. You see, that's what cool people. Oh, indeed, you're right. You're totally right. Negative 6, because we make no mistakes.
No mistakes.
Negative exponents mean that you move the decimal further to the left. Positive exponents mean that you move it further to the right. Because we're cool like that.
Because we make no mistakes.
No, none at all.
Not even tying bow ties.
Oh wait, you're still there. I might as well tell you about other things with our special notation. Say we had 67. We would write that 6.7 to the. We make no mistakes, like we're getting the num lock to the cool 1st power. You see, say we want to multiply that by to the 2nd, 10 to the 2nd power. You see, since we're just this cool, we have a special way using the commutative property of multiplication. You would write it and you see, since there's nothing in yonder area between the parentheses, you multiply because we're too lazy to write multiplication marks. 6.7. That's right, folks. 6.7 and 10, 1. I'm sorry. Let me. Oh yeah, we use Control A because we're just that lazy. Let me move it to 60. Can you still see good?
Mm-hmm.
Okay. So you use commutative property.
Because we make no mistakes.
Because we make no mistakes. And so we could do this 6.7. And you know how to multiply exponents, right? Say yes or die. And
Yes.
cameraman, put up the phone.
I'm not using a phone. I'm using a calculator simply.
Put up the
Because
calculator.
we make no mistakes.
Oh yes.
So we use calculators.
Indeed. So what you would definitely do is you would definitely go here and multiply 4.3 times 6.7 equals, what was that?
28.81. Because we make no mistakes.
28.81.
0.81. No mistakes.
No mistakes. Times, and then we multiply these two exponents, 10 to the second power times 10 to the first power. You would add the two exponents and it would be 10 to the third power. We're too lazy to fix our chairs.
But we make no mistakes.
But we make no mistakes. Think about what we do carefully. And it gets too complicated. 28.81 times 10 to the third power. You move it 3 times to the right, so it'd be 28840.
Why?
That never happened.
We make no mistakes.
We make no mistakes.
No mistakes.
That's purely intentional.
Absolutely. That was purely intentional as well.
Yes. Who didn't fix the chair?
You didn't. Because we make no mistakes.
We make no mistakes.
It was purely intentional.
So, and that is how you multiply such scientific notations.